Hello everyone, my name is Pierre Lemordant and I will present you our work titled How to Optimize Connection between PACS and Clinical Data Warehouse, a web service approach based on full metadata integration. Today, clinical image data analysis is a very active area of research. Artificial intelligence method can use these images as an input, and these images can be used for disease characterization, precision medicine, and early assessment of treatment response. And as we manage a clinical data warehouse solution named eHop, we want to leverage this very important new source of data to use it into eHop. To do so, we ask clinicians and data scientists to help us to define a list of functional and technical requirements. And the result is that we want as much information as possible from imaging data for the widest choice of study purposes. We want to be able to combine imaging data, to combine queries and imaging data and other clinical data. We want to perform queries on the PACS without jeopardizing the care process. We don't need duplication of the PACS data due to safety, GPRD, and IT resources reasons. We want the possibility to browse and view clinical images on the clinical data warehouse interface to perform pre-screening and data quality control. And we will have to leverage the DICOM terminology used in the DICOM metadata. And we want to be able to enrich the metadata during extraction, transformation, and loading process to improve image indexing and retrieval in our data warehouse. So to make the link between our hospital and our clinical data warehouse, we simply developed a web service with DICOM abilities. We have a REST API on one side to communicate with the clinical data warehouse. And on the other side, the server uses the DICOM protocol to connect to the PACS. When the server gets a DICOM file, it is automatically anonymized. And we have designed a plugin system in order to be able to do any kind of processing on the DICOM data. Here we use the plugin which can create a eHop integration file there from the inputs DICOM files. We do not store images. We only take metadata to integrate into eHop database. And when we want to get DICOM file to display it within the eHop with the DICOM web viewer, we call the web service to get the DICOM files from the PACS. And we can cache this file for a certain period of time. The other question when integrating this data is how to manage semantic integration. So DICOM attributes can be ordered hierarchically in the DICOM file, especially in structured reports. So we can't simply rely on the DICOM attributes to make detailed queries. So the solution we found is to build a terminology considering this position of attributes in the hierarchy. Here is an example of what happens when a new DICOM file is integrated. We see that we are building the DCM eHop terminology dynamically. The attributes are simply added to the terminology as series description there, but there is a sequence attribute in DICOM allowing your structures to be formed in the document. So when the sequence attribute is included, the structure is maintained in the terminology. We can see here in the DCM eHop terminology, we see the procedure code sequence contains the subnodes, meaning and value. This is even more important when we integrate structured reports. When we open the X-ray radiation dose report node in this terminology, we have the same complex organization as in the original structured report. So this terminology and the way we are building it makes us able to search for DICOM imaging exam or structured reports with a specific value or for any metadata anywhere in the report or in the DICOM document. Now we made a little proof of concept with our solution. So we started from a study that had been made on data from the hospital, but without eHop. This is our gold standard. And we created, again, this cohort with our clinical data warehouse based on the inclusion criteria used for this gold standard prostate cancer cohort. To start with the results, let's see how we use the DCM EHOP terminology in EHOP. We are in the EHOP clinical data warehouse, and we will make a structured query. So we choose the terminology, we choose our DCM EHOP terminology. And let's say we will look for X-ray radiation dose reports. So we open the corresponding node and we see the structure of this kind of report. We go, for example, to accumulated dose data, and we will make a constraint on the total number of irradiation events. This is a number, so EHOP automatically lets me choose min and max values. So now our query is ready. We will get every report with 6, 7, or 8 irradiation events. We can execute it, and we get the list of matching reports. We take the first one. We can see basic DICOM attributes and a formatted view of the structured reports. And we can see it match the constraints. So we have been able to select the report having a given value for a specific field anywhere in the structure of the X-ray radiation dose report. And we also had to make the images available within the EHOP interface. So let's see how we can access imaging exam with EHOP. So we are using the EHOP query builder, and we will make a simple query on imaging documents. And let's say we are looking for documents with titles containing the word thorax. So we execute the query, and we have the matching documents. So we can select one. And we can see the list of all DICOM attributes. And we can open the DICOM viewer to see the images from this acquisition. EHOP gets the images from the packs through the web service. And I can see the imaging exam with the Papaya DICOM viewer with multiplanar reconstruction. Okay, so I can change view. And now we can go directly to other documents that belong to the same imaging exam, as we can have several acquisitions during an imaging exam. And now let's say we want to see all the documents from the same imaging exam on the same view. So we open the study view, and on the left we have the reports. Here this is a structured report. And on the right we can see all the acquisition from this exam. On the left we have another imaging report. And obviously I can see the CT scan we saw earlier in this global view. So again, it loads from the packs. And we can see all acquisitions and reports from the same imaging exam, the same DICOM study. For the cohort creation evaluation, we tried to create the same cohort as the gold standard cohort with the same criteria. All patients in the cohort were found, and some patients who were not included in the cohort were found in addition in EHOP. So we proved that EHOP on our web service allow us to create a cohort of patients with all their imaging data. To discuss this work, we will return to functional and technical requirements. The integration is done from all metadata. Technically, we use CMove queries on the packs, so we get DICOM files, and we have all available DICOM metadata. We cover all aspects of imaging, anatomy, technique, material, treatments. We can combine queries because we made a full integration of imaging data into the EHOP data model. The hospital packs only uses the DICOM protocol to communicate. And this protocol is not optimized for our use case. So if it were possible, we could use other protocols like WADO. The good point is that we use a cached database. So when a user wants to access to an imaging exam multiple times, we get it only once. We do not duplicate the packs because we only keep IDs to retrieve images when needed. And the possibility to browse and view clinical images come with the full integration of imaging data into eHop, but the viewer could be improved. The semantic integration allows us to query on any DICOM attribute anywhere into a DICOM document. But as we've seen, the DCM eHop terminology is very extensive, and it could be improved to be easier to use for clinicians. And finally, the plugin system can now be used to enrich the imaging data and compute features on the fly. For example, the sequence used during MRI acquisition is not specified in DICOM attributes, and it could be a good use case to compute this information from the input DICOM files. Thank you for listening to me. If you have any question, you can email me at this address. And have a good day.